page 128, it says a die manufacturer, so people who make sets of dice, test to see if the die make show equal distribution of 1s, 2s, 3s, 4s, 5s, and 6s. They roll die 1,000 times to test. Raw count show below. Okay, so the die result, oops. You can get a 1, 2, a 3, a 4, a 5, or a 6. And then what they show with their tests after doing it 1,000 times, they are showing 158 here, 170 here, 164, 154, 178, and 176. Okay, so they're kind of bunched together. So what we want to do is we're going to create our null. So number 5 is create a null. Results equal. Our alternative, results not equal. Agree? And then, so if we do the expected value, that means that you have a 1 in 6 probability. So if you were to do 1/6 of 1,000, you should see these as your results. So just by looking at it, do you think that the you roll 1,000 times? Is that enough times to warrant that we should be getting the 166.7% of the time, or 166.7 times getting those? Is there anything on our data that's totally obscure, out of control? No, I mean 1,000 times in the grand scheme of the universe is 1,000 is not that much. So I think it might be all right. So then remember our result that we're going to do. What was the equation to find this? What was the equation? Something squared. Oh. Yeah, observed minus expected. Cool. Over-expected. Okay. All right, so that means our chi-squared is 0.45 here, 0.07 here, 0.04 here, 0.97 here, 0.77 here, 1, 2, 3, 4, 5, and 0.52 here. Okay, so that answers, filling this whole thing out, answers number 6. Number 7, which outcome produced the largest chi-square value in the context? Explain what having a largest chi-square measures. So it looks like 4 has the highest. So problem number 7, the roll of a 4 has the highest. Okay, if the die are equal likely result, a 4 was the most unlikely. So a 4 is the most unlikely. Is the most unlikely to happen. But it should be a fair die. And then if it says, hey, find the total chi-squared value, that means I'm going to add all these together. So you can just do that on a calculator. So you're going to come out to 2.82. That's just by adding them up. And then which outcome was the least likely to occur if the null is true? Explain how you choose. So the least unlikely would be the 4 is the least unlikely to take place. Okay, this had the largest discrepancy. So this had the largest chi-squared value. And that's all we have with that. Okay, so again, right now, all we've been doing with chi-square is listing our observed, listing our expected. Something that we might have been able to change on this is you could have changed all of your counts into percents. And that would have been fine. So your counts could have been 15.8, 17.0, 16.4, 15.4, 17.8, and 17.6 all as percents. Then you could change your expected values of whatever 1 divided by 6 is as a percent. So I guess 16.67 is what it would be as a percent. So that's it so far. Okay, do we feel comfortable with that? Yeah.
So the smaller x squared values means that it's like more likely to happen, it's like closer to zero. Like if you want to be closer to zero.
Yeah, the closer you are to zero, that means the better your count would have been. That's much closer to your expected value. So being that, what was the smallest? Looks like 3 was the smallest, because 164 is the closest to 166.7. So yeah, but the 4 is the one that seems to be the most unlikely to be taking place. All right, so that is so far chi-squared. We then are going to start 7.3. So I'm trying to fathom how this is going to work with next week. I'm going to go ahead and teach about this, but I'm on one of the pages. So I think what we're going to do, so I'm going to start 7-3 today. Still with me on this adventure? 7-3 we will continue on Monday. Tuesday we have a review. Wednesday we don't have school. Thursday you don't have school, being that you guys are ditching, all right? So that means the only thing that I can fathom, and I apologize for this, is Friday we would have our quiz, and it would be on the notes. So I would truly feel that make sure your notes for 7-1 to 7-3 are complete. Because yes, you can use your notes on the quiz. So this would be a review day, and then testing, no school, because it's school-wide testing other than you all seniors, and this is senior ditch day, SDD. So unfortunately, that's kind of where it'll have to fall. I'm not too worried about it. I don't think you should be too worried about it either. I haven't misled you yet, or maybe I have misled you and you're just very kind and you don't say anything. All right, so 7-3, this is page 48 of our notes. Again, we're just going to get a start on this today. So a chi-square is the measure, the sum of all the chi-square values is the measure of total deviation from the null hypothesis of expected value. What? So the expected value is kind of our null. The chi-squared summation of it is how far away. The larger the sum of the chi-squared values, the stronger the evidence against the null. So the chi-squared, if this is huge, is against the null. The null hypothesis. Okay? One thing that I would imagine you would see is the chi-square graft. It's not a normal curve, but it's not normal. It might appear to be normal, but it is always skew right, meaning you have a longer tail to the right than to the left. Always skew right. Okay, so that's kind of a big thing. One piece of information that you're not going to be tested on, but the peak, so this peak of whatever your chi-squared curve, and this is not in the notes, I don't believe. The peak of the chi-squared curve is always the degrees of freedom minus 2. Okay? So in your y direction, if your degrees of freedom was 20, then the height of your chi-squared curve would be 18, vertically. Okay? This is not totally important, but it's just sometimes when you're looking at a data chart, it might help you. This chi-square distribution is skewed right. We already said that. But but less so as the degrees of freedom increase. So the more degrees of freedom, the more or the less skew right it'll be. So as the degrees of freedom increase, so degrees of freedom increases, the less skew right we will be. Okay, so that's just kind of a finding the p-value in a chi-square test is a straightforward process. Okay, there's another button that's gonna be on the calculator, and I think I have the calculator. I need to pull it up. Calculate the sum of the chi-squared values. The sum will be referred to as the chi-squared test statistic. So to find the p-value on a chi-squared, so the first thing is you are going to calculate the sum of your chi-squared. That's what we've done. That's the final column. And then this is known as the chi-squared test statistic. Okay? Number 2, calculate the degrees of freedom, which is, that's one of the easiest things out there, right? Number of things minus 1. Okay? That are the number of categories minus 1. So categories minus 1. Okay? It's not the sample size minus 1. Okay, so if you rolled 1,000 times, that's your sample size. That doesn't mean your degrees of freedom is 999. On the roll of the dice, you had 6 outcomes that could take place with a single die when you roll it. So your degrees of, if you use that as degrees of freedom, you'd go 6 because you have 6 categories minus 1. So your degrees of freedom would make it 5. Okay, and then use the chi-squared CDF on your graphing calculator. Okay. To find the percentage of chi-squared curve that is farther from the null hypothesis, hypothesized chi-squared value of 0. Okay, so let's find the calculator. Let's bring it up. Get a sip of coffee while this thing's loading. That's good stuff. All right, clear. So under our second distribution, you have a chi-squared CDF, which is number 8. You have a lower, upper degrees of freedom. Paste. Okay, so of course we need to use really large number rather than infinity because the graphic calculator doesn't allow for infinity. Okay. Sorry. All right, so the example that we've gotten, we're continuing with it. We're talking about the cards A, B, C, D, E. Those are baseball cards that came out of boxes of cereal. We added the observed, we had the expected. It should be all 8 because we chose 40 boxes of cereal. We can find the chi-squared by going the observed minus the expected, quantity squared divided by the expected. So that's how you got the 1.125, the 0.125, the 0.5, the 0.125, 0.125. Okay? The total of that chi-squared is exactly 2. So I am on page 49. If I were to go 1.125 plus 1.125 or plus 0.125 plus 0.5 plus 1.125 plus 0.125, that came out to be exactly 2. So we'll use the chi-squared curve with 4 degrees of freedom because we have 5 different cards that we're choosing. Okay, so it's the 5 categories minus 1. The p-value is calculated by going the CDF. Okay, so our lower is going to be p-value is so the lower is the sum of the chi-squared. The upper has to be a big number, so I don't know, million. Sound good? And then our degrees of freedom is going to be 4. And if we do that, that's what it would show up as. We are finding 0.74 roughly, or 0.735. So the p-value calculated from that is rounded to 0.735 roughly. Recall that if p is less than alpha, we reject the null hypothesis. Okay, so let me go back to my board. So they said if p is less than alpha, we reject the null hypothesis. Okay? Otherwise, we fail to reject the null. So if p is greater than alpha, we fail to reject the null. Okay? In this case, a reasonable value would be your alpha is 0.05. Okay? The p-value that we found using this by plugging this in was about 0.735. So this is our new p-value. Okay? So is this p-value less than 0.05 or is it greater than 0.05? Is 0.735 versus 0.05, which one's bigger? So p is greater than alpha. So we fail to reject the null hypothesis. Okay, we don't find strong evidence that the data on those baseball cards is a difference to the 5 cards in the probability of obtaining them in any given box of frosted sugar bombs. I don't know what those are, but we might sound like yummy. There are only 2 assumptions or potential flags to watch for. The sample size must be large enough. In chi-squared test, when all is met, this is met when all of the expected values are greater than 5. Okay? So we don't have that. Random sampling, we must assume each box is randomly chosen from the population at large. Okay? Think about if we were actually to do this test. Do you think on a grocery store shelf, let's say these sugar bombs, they could have 40 boxes sitting right there on the shelves, right? They could have more. They could have less. I don't know. But if you went into a store and just said, I'm just going to take all those boxes from one store, you haven't randomly sampled anything. Okay? Now, if you were to come in and say, okay, I'm going to go to King Soopers within 20 miles of here, which I imagine there's quite a few King Soopers within 20 miles of where we're sitting, and you gave each King Soopers a random value, and then you figured out a counting system to do the boxes, that might be randomness, but that's what's taking place. So, with that known, my friends, I think we can. You guys want a lot of homework tonight? Okay. How about we do page 129, 1, 2, and 3. That's pretty short. That deals with the degrees of freedom. Find the chi-squared curve with 8 degrees of freedom that is greater than 20. Find the proportion. So you all have that information that you just plug into your calculator, and then we'll work from there. Sound good?